NASA's JunoCam, the miraculous fix that saved Jupiter's close-up photos. Imagine a camera clinging to life 370 million miles away, battered by Jupiter's radiation, a force so brutal it could fry electronics in seconds. This was the desperate reality for NASA's JunoCam in December 2023, its images of Jupiter's moon Io on the brink of being lost forever. But here's where ingenuity trumped doom. A Hail Mary fix involving an ancient material science trick saved the day, and the lessons learned are rewriting the playbook for space exploration. Launched in 2011, the Juno spacecraft ventures into the solar system's most hostile radiation environment to unravel Jupiter's secrets. JunoCam, its external color camera, was designed to survive for 8 orbits. But by orbit 47, radiation had begun crippling its power system, a damaged voltage regulator threatening to turn the camera into a $700 million paperweight. Enter annealing, a process akin to baking damaged silicon back to health. By heating JunoCam to 77 degrees Fahrenheit 25 degrees Celsius and cooling it slowly, the team hoped to repair microscopic radiation scars. "We were gambling," admitted Jacob Schaffner, JunoCam's engineer. "Silicon can heal, but would it work in space?" The first attempt brought a few clear orbits, but by orbit 55, images were unusable, streaked with noise like a TV on the fritz. With Io's volcanic landscapes looming, the team tried extreme annealing, maxing out the heater. Days passed with no improvement, until, just before the Io flyby, the camera roared back. On December 30, 2023, JunoCam captured Io's North Pole in stunning detail, revealing unseen volcanoes. The feat was hailed at a NASA conference, but the victory was short-lived. By orbit 74, corruption returned. So why does this matter? Juno isn't just surviving, it's teaching us how to build radiation-proof satellites for Earth and beyond, says Principal Investigator Scott Bolton. But here's the controversy: is temporary hacking like annealing a viable strategy for deep space, or a band-aid on a broken system? As private satellites and Mars missions face similar perils, the question looms: can we afford to rely on Hail Mary repairs, or must we rethink spacecraft design entirely? Share your take. Should space agencies prioritize resilient hardware or clever workarounds? NASA's JunoCam, how heating rescued a space camera 370 million miles away. NASA pulled off an engineering miracle by remotely repairing Jupiter's dying camera from 370 million miles away. When the Juno spacecraft's camera began failing under Jupiter's brutal radiation, mission engineers revived it multiple times using a technique straight out of a sci-fi novel, heating the damaged components until they essentially healed themselves. But here's the twist most space enthusiasts miss: this wasn't planned maintenance. It was a desperate gamble that rewrote the rules of deep space survival, and let me break this down clearly for you. The JunoCam was only designed to endure 8 close passes of Jupiter's lethal radiation belts. When image noise and streaks appeared, NASA carefully warmed the camera to a gentle 25 degrees Celsius 77 degrees Fahrenheit, much like reheating leftovers in your oven. This annealing process, where heat realigns damaged materials, initially fixed the issues. However, just days before Juno's critical close flyby of Jupiter's volcanic moon Io, the camera started failing again. That's when NASA took radical action. They cranked the heat to maximum survival temperatures. And the result? Images so dramatically improved that we got unprecedented views of Io's fiery surface, and now, here's where it gets controversial. This emergency repair challenges everything we thought possible for spacecraft longevity. Despite being exposed to radiation levels that would instantly fry your smartphone, Juno's instruments, thanks to repeated heating cycles, have now endured 74 Jupiter orbits over 9 years, far beyond their planned lifespan. NASA's so confident in this technique that they've adapted it for other instruments aboard Juno. But here's a burning question: Should we risk pushing hardware this far in such an extreme environment? If the camera fails permanently during a crucial observation, was it worth stretching its lifespan? And beyond the camera drama, Juno's discoveries have revolutionized planetary science. We've learned Jupiter's magnetic field is 10 times stronger than predicted, enough to visibly affect atmospheric chemistry. The probe also revealed stunning differences between Jupiter's chaotic North Pole and its structured South Pole, solving mysteries that baffled astronomers for decades. Plus, its Io flybys captured the most detailed volcanic activity ever seen beyond Earth. Just think, this mission, originally scheduled to end in 2018, has been extended to September 2025 because of its ongoing success. But here's my provocative take. Does repeatedly reviving aging equipment actually hinder funding for newer, more capable missions? I'd love to hear your thoughts in the comments. Do you support pushing hardware to its absolute limits, or should we retire probes more promptly to make room for next-generation explorers? NASA hacks JunoCam, heat repair saves Jupiter probe camera for stunning Io flyby. Imagine capturing the breathtaking beauty of space, only to watch it fade into oblivion. That was the daunting challenge NASA faced when the Juno spacecraft's camera started to degrade after its 47th orbit of Jupiter. But here's where it gets controversial. Instead of the usual route of replacing the hardware, which was out of the question due to Juno's staggering 595 million kilometers from Earth, NASA engineers took a bold and risky approach. They decided to heal the camera by heating it up, a technique known as annealing. It's like giving the camera a fever to reverse the damage caused by radiation. But this wasn't a one-time fix. Initially, the camera seemed to be back in action after a first round of annealing at 77 degrees Fahrenheit, just enough to alter the silicon at a microscopic level. However, the issue resurfaced, leading to a second, more intense round of heating just before a close flyby of Jupiter's moon Io in late 2023. The gamble paid off, and JunoCam resumed high-quality imaging up to orbit 74. This experiment wasn't just about saving a camera. It opened up new possibilities for in-situ repairs, offering valuable insights into how we can maintain spacecraft resilience over longer missions. And this is the part most people miss, the camera started showing new signs of degradation after orbit 74. Will NASA attempt another fix, or has the camera's mission come to an end? This isn't just a story about technology. It's about the future of space exploration. As we venture deeper into the cosmos, the ability to repair and maintain equipment remotely will become crucial. But here's a thought-provoking question for you. How do we balance the risks and rewards of such daring fixes? Do we push the boundaries of what's possible, even if it means taking on significant risks? Share your thoughts in the comments below.